Failure mode effort analysis procedure. The process for conducting an FMEA is straightforward. The basic steps are outlined below. The first step is describe the product, process, and its function. An understanding of the product or process under consideration has to be clearly articulated. This understanding simplifies the process of analysis by helping the engineer to identify those product or process uses that fall within the intended function and the one that falls outside. It is important to consider both intentional and unintentional uses since product failures often ends in litigation which can be costly and time consuming. Second step is create a block diagram of the product or process. A block diagram of the product or process should be developed, and this diagram shows major components or process steps as block connected by lines that indicates how the components or steps are related. The third step is complete the header on the FMEA form sheet. FMEA table headers vary since they are supposed to be customized according to the requirements of the company using them. Generally, the header requires information such as product, process, system name, component, step name, product designer or process engineer, name of the person who prepared the FMEA form, FMEA date, revision level, and revision date. These headings must be modified as needed. The fourth step is enumerate the items like components, functions, steps, etc. that makes up the product or process. The table shows a simplified FMEA sheet and the items that makes up the product or process must be listed. Fifth step is identify all potential failure modes associated with the product or process. A failure mode is defined as the manner in which component, subsystem, system, process, etc. could potentially fail to meet the design intent. Examples of potential failure modes include corrosion, hydrogen embitterment, electrical short or open, torque fatigue, deformation, and cracking. The sixth step is list down each failure mode using its technical term. A failure mode is one component can serve as a cause of a failure mode in another component. Each failure should be listed in technical term. Failure modes should be listed for the function of each component or process step. At this point, the failure mode should be identified whether or not the failure is likely to occur. The seventh step is describe the efforts of each of the failure modes listed and assess the severity of each. For each failure mode identified in the column 2, a corresponding effort must be identified and listed in column 3 of the FMEA table. A failure effort is defined as the result of a failure mode in the function of the product or process as prescribed by the customers. Examples of failure efforts include injury to the user, inoperability of the product or process, improper appearance of the product or process, degraded performance or noises. A numerical ranking must be established for the severity of the effort. A common industry standard scale uses 1 to represent no efforts and 10 to indicate very severe, with failure efforting system operation and safety without warning. The column 4 of the FEMA table is used for the severity rating of the failure mode. The next step is identify the possible cause for each failure mode. A failure cause is defined as a design weaknesses that may result in a failure. The potential cause for each failure mode should be identified and documented. The causes should be listed in the technical term and not in the terms of systems. Like symptoms. Potential causes are listed in column 5 and examples include improper torque applied, improper operating conditions, contaminations, algorithms, improper alignment, excessive loading and excessive voltage. The ninth step for failure mode effort analysis is to quantify the probability of occurrence of each of the failure mode causes. Every failure cause must be quantified and will be assigned a number which identify how likely that causes has a probability of occurring. A common industry standard scale uses 1 to represent not likely and 10 to indicate inevitably. The PF values for each of the failure causes are indicated in column 6 of the FMEA table. The next step is to identify all existing controls that contribute to the prevention of the occurrence of each of these failure mode causes. Current controls are the mechanisms that prevent the cause of the failure mode from occurring or which detect the failure before it reaches the customer. The engineer should now identify testing, analysis, monitoring, and other techniques that can or have been used on the same or similar product process to detect failures. Each of these controls should be assessed to determine how well it is expected to identify or detect failure modes. Each of the controls must be listed in column 7 of the FMEA table after a new product or process has been in use. Previously undetected or unidentified failure modes may appear. The FMEA should be updated and plan must be made to address those failures to eliminate them from the product or process. The next step is to determine the ability of each control in preventing or detecting the failure mode or its cause. Detection is an assessment of the likelihood that the current control will detect the cause of the failure mode or the failure mode itself, thus preventing it from reaching the customer. As usual, a number must be assigned to indicate the detection effectiveness of each control, that is DET. The DET number are shown in column 8 of the FMEA table. Next step is calculate risk priority number RPN. The risk priority number is a mathematical product of numerical severity, probability, and detection rating. RPN is equal to severity into probability into detection. That means SEV into PF into DET. The RPN that is listed in column 8 of the FMEA table is used to prioritize items required for additional quality planning or action. The next step is determine recommended actions to address potential failures that have high RPN number. A high RPN needs immediate attention since it indicates that the failure mode can result in enormous negative effort. Its failure causes a high likelihood of occurring and there are insufficient controls to catch it. Actions items must be defined to address failure mode that have high RPN values. These actions could include specific inspection, testing, or quality procedures, selection of different components or materials, derating, limiting environmental stresses or operating ranges, redesign of the items to avoid the failure mode, monitoring mechanism, performing preventive maintenance, and inclusion of backup systems or redundancy. The column 10 of the FMEA table is used to list the applicable action items. The next step is implement the defined action. Assign responsibility and a target completion date for these actions. This makes responsibility clear-cut and facilitate tracking. The responsible owner and target completion date must be indicated in column 11 of the FMEA table. The next step is review the results of the actions taken and reassess the RPN's number. After the defined actions have been taken, reassess the severity, probability, detection, and review the revised RPN number. The new RPN should help the engineer decide if more action are needed or if the actions are sufficient. The columns 13, 14, 15, and 16 of FMEA table are used to indicate the new SEV, PF, DET, and RPN respectively. The final step is to keep the FMEA table updated. Update the FMEA as the design or process changes. The assessment changes or new information causes the SEV, PF or DET to change.